All right, so here is this second Lewis Structures assignment, and this is for the people that need to do the quiz retake in my class. And for any other teacher that uses this, well, go for it. All right, so in this situation, just a reminder, since we are not using any of these elements right here, we don't really care about these, we're going to block these out. And in actuality, notice we go from groups 1, 2, 13 goes to 3, so it's 3, 4, 5, 6, 7, and 8. This also corresponds to the number of valence electrons in each element. For instance, hydrogen has one valence electron, as shown here. Lithium has another valence electron in its outer ring. Notice it's 1. Sodium has a 1. Potassium has a 1. This is important to create these drawings here. Beryllium has 2 outer valence electrons. Magnesium has 2. And if you notice aluminum, it has 3. Silicon has 4. Phosphorus has 5. So we're going to use these values to actually create these drawings. So let's try it out. So here we have H2O. So in this case, I write down hydrogen twice because I have a 2 here. And I hover over hydrogen and I click on it. Notice I have 1. And by the way, this is on ptable.com. So I put 1 dot. Now I go to oxygen and I create that. And let's go to oxygen and see. Notice it's in group 16 or 6. So it should have 6 valence electrons. And there it is, 6 valence electrons that are ready to interact. 2, 3, 4, 5, 6. And notice when I place my dots, I place them one at a time going all the way around. And I go 1, 2, 3, 4. And then I made the next one 5, 6. But in this case, it was 5, 6 here. All right. So the wrong way to do it would be like this. Don't do this. This is bad. This is good. All right, so all we do here is just connect the single dots because the lone pairs will not interact. So now we have created water. So now notice this will just create H2O. So no, the single electrons are being shared. The single valence electrons are being shared. So now we redraw this neatly. We have a hydrogen here, another one here, and then the lone pairs. All right, let's try out another one. So here we have H2S. So I'm going to write out hydrogen. Remember, it's the same element, so it's just 1 dot. Now we have sulfur. So sulfur is right below oxygen, so we can take a guess as to what this is. Notice this is group 16, so this is still 6 valence electrons. So let's go ahead and draw that. 1, 2, 3, 4, 5, 6. Notice the placement on these dots is different than over here. That is completely meaningless. It's just that I started my first dot in a different location. So anyways, we connect the single dots, but before we do, let's identify our lone pairs. These electrons will not interact. So here's one hydrogen connecting there to sulfur, and here's a valence electron from this hydrogen connecting to this sulfur. There are no more singles, so we are good. And there it is. And we're pretty much done with both of these items. All right, so now we're going to do some of these other items that are a bit larger. So let's focus on this molecule here. This one has a funky name, so I'm not even going to try saying the name. So it is going to be carbon. Notice we have hydrogen and then iodine. So let's go ahead and do hydrogen, hydrogen, our 2 iodines. And let's go ahead and start this off. So carbon, we notice is in group 14. So it has 4 valence electrons right here. So I go ahead and place 1, 2, 3, 4. Hydrogen still has 1. It will never change. Iodine, new element. So now notice iodine has all these values, but these are just the number of elements in every ring. So this is in the first ring, there are 2 electrons. In the second ring, there are 8, and 18, and 18 in the following rings. And finally, in the outer shell, we have 7 valence electrons. This is all we care about right here, this value here. We do not care about these other values. So 7. So go ahead and put 1, 2, 3, 4, 5, 6, 7. over here. 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and circle my lone pairs. I have these right here. These will not interact. So now we're combining, and by the way, the element that will be in the center, several people ask about this, it's just going to be, it's usually the element with the most single dots. In this case, it's carbon. So we'll go ahead and bind one hydrogen here. This one goes here, and the placement does not matter. I'll explain why later. Here's iodine, and here's another iodine. So now we combine this, and it is carbon to hydrogen over here. We have an iodine down here, and we keep those lone pairs. And notice I'm drawing the lone pairs around the iodine, not where the lone bond, where I have this bond here. So I have the other iodine, and I continue to put the lone pairs, 3 lone pairs. There's 1, 2, 3 around, and this is our final drawing. So use this logic to answer this one, this one, this one, and this one here. All right, let's try one more. So here's a complicated one. So we're going to go ahead and try this one. So here we have carbon, hydrogen, and hydrogen. Now keep in mind, oxygen is also here. This is going to be a funky molecule. All right. So in this case, carbon still has 4 dots. So 1, 2, 3, 4. Hydrogen has 1, 1. And then oxygen, we did this earlier, but we'll go over it again, is in group 16. Click here and notice 6 valence electrons. So we have 1, 2, 3, 4, 5, and 6. Okay, so let's try this out. So in this case, we have a bond here to hydrogen, another one here to hydrogen. Notice we have the lone pairs for oxygen. So those will no bond, and we have one single dot, another single dot, and here are some other single dots. So let's go ahead and bind that, and put that here, and this one goes over here. Now let's clean this up. So we had carbon connecting with one hydrogen up here, another one in this area, and then we had a double bond, notice 1, 2, to oxygen. So that's pretty much it for that one. So anyways, try out all of these other molecules and check with the teacher, see if they're correct.